In this lecture, we're going to continue our study of bones by looking at how we maintain the bone, so the mechanisms of homeostasis and maintenance of bone tissues, and then we'll spend some time looking at the different functions that the bones serve in the body. So, living bone is constantly in a state of being remodeled. We damage our bones every day. And, the damage isn't great, but it is tiny little microfractures that can build up over time and severely weaken the bone. And so as we damage our bones, the osteoclasts, and they're shown here, it's the little red cells, these osteoclasts will move into the damaged area, and they release acids that help to dissolve the bony matrix, and they release enzymes that help to break down the protein fibers, and these minerals that are released and the protein the protein amino acids are all released back into the bloodstream. And then osteoblasts will move in. They generally come in along with new blood supply, or from underneath the periosteum and the endosteum. There are colonies of osteoblast forming cells, and the osteoblasts will move in and replace that bone matrix, mature into osteocytes, and that area can be strengthened, and generally, as part of going to repair, the area is enlarged. It's so the bone that replaces the damaged bone that was removed is stronger, denser bone. Now, this remodeling doesn't occur at uniform rates throughout the body. Some areas face greater damage, and so they are replaced more often. So, for instance, the spongy bone that we find at the proximal epiphysis of the femur, the head of the femur, the place where that ball meets the socket of the hip, it may be replaced fully replaced 2 to 3 times every year, because of all of the micro damage that region of the skeleton suffers. But the diaphysis of the femur, which is built of compact bone, really dense, really hard, really strong, it may not even be touched. There may be just small amounts of repair and replacement in that area. So depending on where in the bone, in the body, the bone is, and the kind of bone it's built from, spongy bone is overall weaker than compact bone, then that's, those areas that have more spongy bone and are subject to more stress are going to be replaced and repaired more frequently. So there are a number of factors that can play a role in bone development and bone repair, and nutrition is a big one. And there are a number of vitamins that are involved in bone maintenance because of their effects on the cells or on the minerals, the maintenance of the minerals that we have in the body. So vitamin D is a very important vitamin for calcium absorption. Without vitamin D, the small intestine will not absorb sufficient amounts of calcium to allow for proper bone growth or development or repair. And so vitamin D is very important. If a child lacks vitamin D, then what happens is that the bones become deformed as they develop. Here you can see rickets, which is it's one of the typical appearances of rickets is this bow-legged because of the weight of the body pushing down on the legs. And without sufficient vitamin D, the legs cannot be properly calcified. And so the bones are soft, they deform, and then eventually, the slowed processes of ossification eventually complete, but leave the bones very deformed. Vitamin A is important, not just to skin, but also to the activity of osteoblasts and osteoclasts. Oops, I'm sorry, I forgot to mention that if there's vitamin D deficiency in adults, It's referred to as osteomalacia. So osteomalacia is vitamin D deficiency that causes poorly calcified bones in adults. If it happens as children, then we talk about it as rickets. As I was saying, vitamin A is required for normal osteoblast and osteoclast activity, and if there is not sufficient vitamin A in the body, it will slow down bone development. And then finally, vitamin C is very important for the synthesis of the protein collagen, and therefore for the collagenous fibers that are found within the bone that strengthen the bone. And so if there's a deficiency in vitamin C, then the bones will appear very slender and they'll be very fragile. So we have this very characteristic of small bones that are not very strong. And then exposure to sunlight also plays a role, because it is through sunlight exposure that vitamin D levels are maintained in the body. There's a cholesterol compound that's produced at the digestive tract into this inactive form of vitamin D, and as it circulates through the blood, it is activated, and then the liver and the kidney will fully activate the activated compounds into vitamin D that will then be a signal to the gut to bring in calcium into the body as it's digesting. Hormones also play a very significant role in bone development. Growth hormone, it is abbreviated as GH, it's secreted by the anterior pituitary gland. And growth hormone stimulates the cartilage cells at the epiphyseal plates to divide. And so with lots and lots of growth hormone, we see lots and lots of cartilage production, and in turn, we will eventually see longer bones as a result of growth hormone. So if there is insufficient growth hormone, then the condition is referred to as pituitary dwarfism. And this is a real picture of a girl who has experienced pituitary dwarfism. If there's excess growth hormone produced, that causes pituitary gigantism. And again, we've got a real picture of a man who he's something like 8, almost 9 feet tall, this fellow. He experiences pituitary gigantism. So that's as a child. But if after the bones have completed development, the epiphyseal plates are fully closed, then if there's an excess of growth hormone, the condition is referred to as acromegaly. There have been some famous folks with acromegaly. If you've ever watched The Princess Bride or were a fan of 80s or 70s and 80s wrestling, Andre the Giant experienced, he's dead now, acromegaly. And the book shows a series of pictures of a woman who, as a young woman, had features that we would expect for a young woman, but because of the effects in acromegaly, as she aged, her hands, her feet, and her jaw became significantly enlarged. Those are bones that can still grow even after epiphyseal closure and the reaching sexual maturity. And so as an older woman, you can see the changes as she aged, as acromegaly had its effect on her hands, the structures of her face, and her jaw, and her feet. So growth hormone is clearly very important. There are other hormones that help to influence bone development. One of them, a second, is thyroxine. It's one of the thyroid hormones. So it's secreted by the thyroid gland. The abbreviation for it is T4. At the end of next year, we'll get into the endocrine system of the second semester course. We'll start talking the endocrine system, and we'll talk more about thyroxine then. But the reason it's called T4 is because 4 iodines attach to this molecule. So thyroxine. And thyroxine has a great effect on the release of growth hormone. And so in response to thyroxine, we see an increase in osteoblast activity that will help to speed epiphyseal closure in a maturing person. Parathyroid hormone, PTH, is secreted by the parathyroid glands. These are 4 tiny little secretory glands that are found on the posterior surface of the thyroid. It's an important regulator of blood calcium. Calcium is super important to the body. When we get to the muscular system or to the nervous system, we'll see that calcium plays really important roles in the function, in muscle and nervous function. So, maintaining homeostasis around calcium is super important as well. Parathyroid hormone responds to low calcium levels. So if we see low calcium levels in the blood, parathyroid hormone is released. It stimulates the activity of the osteoclasts. So the osteoclasts move in, they start dissolving the bony matrix and digesting the proteins, the collagenous fibers and other proteins found in bone. And as a result, they increase the amount of blood calcium available because all of that calcium that is being broken down is being released into the bloodstream. So thyroxine and parathyroid hormone. Calcitonin also plays a very large role. It responds to high blood calcium. So if calcium is too high in the blood, then calcitonin, CT is its abbreviation, is released. Calcitonin is produced by the thyroid gland, and release of calcitonin decreases the activity of osteoclasts. So we slow down osteoclasts in response to calcitonin being released by the thyroid gland. Okay, so the last of the hormones that I want to talk about then are the effects of estrogen and testosterone. Estrogen is secreted by the ovaries, testosterone by the testes. There are other glands that secrete them. These two hormones, or testosterone especially, in the body. But we're really, the primary source of estrogen and testosterone are the ovaries and the testes. And it is, as sexual maturity begins, as puberty begins, it's the production of these two hormones that really bring on the growth spurt that we see as part of the secondary sexual characteristics. So, so that big burst of growth that's associated with puberty is produced by these two hormones. And it's interesting because estrogen and testosterone really promote both the growth of the cartilages there at the epiphyseal plates and of the bone cells at the epiphyseal plate. So again, if we think of what's going on there as a race, so here's the epiphyseal plate, and we're producing at this side, we're producing cartilage, growing toward the center of the bone. Oops, I was trying to get it written in there, but you can tell that's cartilage. And at this portion of the bone, we're getting bone growth. So it's that race. If the cartilages can grow faster than the bone does, then the plate, the growth plate here, stays open and the bone can lengthen. Estrogen has a stronger effect on bone growth than testosterone does, interestingly enough. And so this causes, as soon as estrogen gets in there, we see an increase in cartilage growth, but an even greater increase in bone growth. And so we see epiphyseal closure more quickly in women, on average, than we see epiphyseal closure in men. So women frequently, I in classes I'll have everybody put up their hand and then have them put down their hands, as I say, an age where they stop growing in height. And for most of the women, by the time I get to age 15, most of them have their hands down. The men keep their hands up frequently until 18, 19. And, in talking with my father-in-law, he was born in the late 30s, he said he didn't reach his full height until he was in his early 20s, by age 21. So men have these epiphyseal plates staying open longer, and that allows greater height growth in compared to women. So men generally are taller than women because it takes longer for the bone to overtake all of the cartilage growth. And that's just because estrogen has a stronger effect on bone growth. Stress on the bone can also alter how rapidly or how quickly an area, the activity of the bone cells in that area. So as we do damage, and what we're seeing here is bone from a joint. Everything here and above is hyaline cartilage. Everything from here downward, with the exception of this opening here, is this is all bone. So bone below, cartilage above. And you can see these fractures that I was talking about. Micro cracks here, following here, that can occur at the surface of the bone. And so here at a joint, we would see greater osteoclast and osteoblast activities as the osteoclasts move in, they clean up all the bone, the damaged bone material, and then the osteoblasts follow behind, and they get to work rebuilding the bone. So clasts clear it out, and blasts will move in and rebuild, and eventually those osteoblasts will be sealed up in their lacunae, and they will become osteocytes. So use of bones causes bone growth, but if you slow down the use of bones, then that will also show a concomitant decrease in bone density and bone strength. So, for instance, we send the astronauts off to the International Space Station. We got a guy there right now. He and his twin brother is at home. He's up there experiencing the effects, and they're going to do lots of comparisons to when he comes back home to look at what are the effects caused by long-term space travel. But one thing that we see is that osteoclasts are not slowed down, but osteoblasts are slowed down. And so the clasts are working harder than the blasts, and that weakens bone that is not being stressed. Same if we immobilize a limb because of, say, a broken bone, then while the limb is not allowed to move for those 6 weeks or so that the bone is knitting and healing, during that time, the entire immobilized bone can have its density reduced because of this lack of use. So using bones strengthens them. Not using them will weaken them. And so one of the recommendations to women especially is that during their peak estrogen production years, using the bones a lot will help to increase bone density and help to delay any effects of osteoporosis till later in old age. So bones will stay stronger longer if during the peak estrogen years there's a lot of bone use, because all that repair will strengthen and create greater density bones. Alright, so now we're going to wrap up this lecture by talking about some of the functions of the bone. And I think the first ones here are pretty straightforward. Bones are very supportive. They provide the hard framework that supports and anchors all the soft tissues of the body, as well as providing attachment points for the tendons and the ligaments and skeletal muscles that are all involved in moving or stabilizing the body. And I love this cartoon. Here we are with the skeleton, and this is what we would look like without a skeleton. So support is definitely very important. Protection is another very important function. We protect the soft tissues and internal organs of the body with bones. So the cranium protects the brain, the vertebra protect the spinal cord, and the ribs provide a lot of protection for the organs of the thoracic cavity. And also, down at the pelvis, there's lots of protection there for the internal reproductive structures of females. Movement, of course, it's the skeletal muscle tugging at bones that allows the bones, the bones become or act as levers that are then used to move the body. Hematopoiesis, hema is all about blood. Poiesis is production. So red blood cell or blood cell formation. So we produce in red bone marrow the red blood cells, the white blood cells, and platelets. And we see lots of the spongy bone in the skull bones, in the ribs, the sternum, the scapula, the hip bones, the vertebra, and in the epiphyses of the long bones. So those are the primary sources of red blood, or of red blood cells, white blood cells, and platelets are the spongy bone found in those regions. And then last of all, storage is a very important function for the bones. We store fat in the medullary cavity as yellow marrow, so the yellow bone marrow there, and we can see lots of this yellow bone marrow here in the medullary cavities of these soup bones. And it's the big reason that dogs are so interested in bones, is because there's so much delicious marrow, yellow marrow there. But we also see storage of minerals in bone matrix as well. So 99% of our calcium, for instance, is found in storage in the bones. And calcium is super important to the body. It's required for muscle contractions, for nervous impulses, for blood clotting, for movement of materials across membranes, lots and lots of ways that calcium is really important to the body. And 90% of phosphorus is found in the bone matrix as well. And phosphorus is super important for DNA, for RNA, and for ATP. We can't build any of these molecules without phosphorus in the body. Interestingly, I should have mentioned this before, in newborns, almost all of their bone marrow is red bone marrow, but as we age, more and more of it is converted into yellow marrow. So there we are. The functions that we associate with the bones, especially as a storehouse, not only for energy, but also for all of the very important minerals that are found in the body. Okay, so that's it. If you have any questions, do not hesitate to make contact with me. See me in office hours, and we can talk more.